Welcome back to Think Thrice Problem Solving. Today we're going to be solving a Putnam Exam problem from 2021. So let's take a look at it. So this is the Hopping Grasshopper. So a grasshopper starts at the origin and he always hops a length of 5 and ends on coordinates that are integers. What is the smallest number of hops to get to the point 2021, 2021? So go ahead and pause the video and give this a shot if you'd like to. It's a little bit tricky, but the hard part is actually showing that you have the optimal solution. But if you're ready, let's go ahead and get started, and let's work toward our solution. So we have a few rules here. So we know that the grasshopper starts at the origin. So he's going to start right at our point 0, 0 here. And we know he hops with the length of 5. So what are the possibilities there? So let's look at our triangle here. So if we have a distance of 5, what can our x and y be? So we know x squared plus y squared is going to equal 25. So clearly, we could have x or y be equal to positive, negative, or 5. So positive, negative 5, comma 0 will work, and 0, comma positive, negative 5 will work. But we could also have a 3, 4, 5 triangle. So if I have positive, negative 3 squared plus positive negative 4 squared, that's going to be 9 plus 16, which is also 25. So I could also have any of the positive negative 3, positive negative 4, or positive negative 4, comma positive negative 3. Okay, so what does that look like? So if I draw those out, I could move up, right, down, left, or I could move 3, 4, 4, 3, or the negative in this fourth quadrant, or I can move to the third quadrant, or I can move to the second quadrant. So all of these are a distance of 5, and they all end at a point that is integer coordinates. Okay, so our next question is, which one of these is going to be the best? So if we go ahead and draw, so we have some point way out here that's going to be 2021, 2021. And since those are the same, if we were to draw that as a vector, it would be in the direction of a vector that is 1 over square root of 2, 1 over square root of 2. So it's going in the same direction as that vector. So we notice that if we take the dot product of any of our existing vectors to get the projection, we can look at the projection on this vector. And we can see that these two guys, our 3, 4 and our 3, negative 4, are going to give us the largest projection, so the most forward progress along that vector. So how much is that progress? Well, let's take that vector 3, 4, for example. Take the dot product with 1 over square root of 2, 1 over square root of 2. And I'm going to get 3 plus 4 over the square root of 2, which is 7 over the square root of 2. Okay, so I'm moving 7 over square root of 2. This is the maximum distance that I can travel in the direction of 2021, 2022, 1. Okay, so that's the maximum distance I can move at any one time in the direction of my point way out here at 2021, 2021. If I do 5, 0, or 0, 5, I'm going to get 5 over square root of 2, which is clearly less in the direction of 2021, 2021. So if this is the maximum forward progress that I can make, how far do I have to go? So I'm going to have to go 2021, if I'm going to the point 2021, 2021, then I'm going to go, if I draw that triangle, So 2021, 2021. So this length over here is going to be square root of 2 times 2021. So if I look at that, and I look at this distance, so the square root of 2 times 2021 divided by my maximum distance that I can travel at any given time in that direction is going to be 2 times 2021 divided by 7, which is going to be 42 divided by 7, which is going to be 5, 7 with a remainder of 3. Okay, so the minimum number of moves I can make at best case scenario would have to be 578. Okay, so I've just shown that the minimum number of possible moves would be 578. So let's take a look at this. So if I look at my different possible moves up here, then the best possible way that I can move would be to take a step in the 3-4 direction, or 4-3, and then a step in the 3-4. And then what I'll do in that process, so this guy is 4, this is 3, this is 3, so this is 7 total, and then this up here would be 7. So in 2 moves, I'm moving to that 0.77. So if I rotate between those 2, then I'm moving a total of 7. So let's go ahead and do that. So we do 2 moves. We'll go out 7, and let's look at that 2021. So 2021 divided by 7 is going to give us that 577 divided by 2. So I'm going to end up with 288. So if I move 288, so 288 sets of 7, that's going to give me all the way out there, but that's not quite out to the end. So 228 times 7 doesn't get me all the way out there. Okay, so what we notice now as we go through here is that I'm out at 2016, which still leaves 5 more. So I would still need to move 5 more to the right, or 5 left if I was looking at the other direction. So I'm still not all the way out there, but what do I notice? I notice that this 5 right and 5 left are exactly my 2 other moves. So what we're going to do here to get to my end point is we're going to do 288 moves in the 3-4 direction. We're going to do 288 moves in the 4-3 direction. And then we're going to do 1 move in the 0-5 direction and 1 move in the 5-0 direction. And if we add all these guys up, we're going to get exactly 2021 and 2021. How many moves did we make? We made 288 plus 288 plus 1, which is exactly 578, which we already showed was our absolute minimum. So it looks like the fastest we can possibly get out here, the best possible way we can get from the origin out to that point 2021, is going to be to take 288 steps in the 3-4, 288 steps in the 4-3, and then 1 step in the 0, 5 direction, and 1 step in the 5, 0. Okay, so if you'd enjoyed this video, please like and subscribe. If you have any of your own problems that you'd like me to solve in the future, please go ahead and submit them. I'll be working a few more Putnam Exam problems in the near future. Otherwise, as you're going about your business, make sure to always think thrice as you're working through your problems.